having one of those sell everything and move to town moments. That's an 18 Chevy Cruze. It's got some kind of horrible death rattle. Kind of sounds like a timing chain. Not sure. I think we're going to have to crack it open though. The Thomas skid steer, it's fine. It's just got a wee bit of a flat tire. Also, the bucket cylinder is starting to leak pretty bad. Gonna have to fix that one of these days. And the pressure washer, already in progress. Let's start with that one. This little beauty is a Hotsy hot water pressure washer. It's nicely patinaed, been around since Christ was a cowboy. The pressure part works, the hot part does not. I had my mind made up to replace it, but it turns out a new one's going to cost about $5,000, and even a good used one's about half that. So before we pull the trigger, maybe we should try and figure out what's wrong with it. There really isn't much to these machines. If you're not familiar, it's just a regular pressure washer, but the outlet side is hooked up to a steel coil that's wrapped around the inside of this drum, and at the bottom there's a flamethrower that burns diesel or kerosene, and it heats up the water inside the coil. That's the part that doesn't work. This burner setup should be the same as what you'd find in a waste oil burner or in a lot of heating systems. There's a motor that spins a squirrel cage fan to move some air. It also spins this pump that pumps fuel from the tank up through this tube and into some kind of an injector, I think. And then this gizmo here is an igniter. It's kind of like a coil, and there's some contacts that act like a spark plug that gives you ignition. So in order to work, this thing needs air, fuel, and ignition. And it's got to be missing at least one of those things. So I think I know what's wrong with it. I'm going to walk you guys through the steps. I couldn't find a whole lot of information about troubleshooting these systems. Maybe because they're so simple, but I'll show you what I found. Here we go. Okay, we learned a lot here. We have spark, and we know this gizmo is good. We have fuel at the bleeder, which means we have fuel coming in, and we have the ability to pump that fuel, but we're not getting any fuel out of the outlet up to the injector where it can actually be burned. There's a shutoff solenoid here. I suspect that might be the problem. That's why I've got these leads hooked up. Let's test it electronically. I couldn't find a wiring diagram for this dinosaur, but I think this is how it works. So the switch, this switch here, has two positions, pump and burner. Anytime it's in the burner position, the pressure washer pump runs, the blower motor / fuel pump motor runs, and the igniter fires. But it will not open the fuel solenoid to actually turn on the burner without closing the flow switch and the temperature switch. So this is the flow switch here. It closes when it sees water flowing past it, so the burner will only come on when you pull the trigger on the gun. This is the temperature switch here. It's kind of like a thermostat, but backwards, so it opens when it reaches the cutoff temperature. Right now it's set for just short of boiling. So let's fire it up and see if we have power at the solenoid when I pull the trigger. I pull the trigger and we have 240 volts across the solenoid, but the fuel does not flow. So for $70, I purchased a new solenoid. Let's put it in and hope for the best. Yeah, I guess it's roughly the same. Oh, God. Oh, let me go switch that fitting over. Well, I got the solenoid all wired up, but it just occurred to me that all I have to do is remove the solenoid and then run the pump, and I should see fuel come squirting out the bottom. So let's try that real quick. And we got nothing. So this solenoid was not the problem. Dang it. Part scanning has failed. So I don't know what the problem is. It's got to be a bad pump, right? I think we're going to take this cover off. There should be a strainer inside if I'm looking at the diagram right. I don't know if it's going to do us any good, but at least we can have a look at it. Pumps really aren't too expensive, about $100. So if we have to replace it, it's not a big deal. Kind of wish I would have known that before I bought the solenoid. But that's what you get when you don't know what you're doing. Oh, there's probably a gasket that we're going to ruin when we do this. Let's see, turn the fuel off. Ooh. Yeah, that looks pretty nice. I'm sure that's not helping us, but I still don't think it's the problem. Alright, let's go a little deeper. It's already broke. What are we going to do? Break it more? We got some springs. Aha. I think I see the problem. Now, that's a bummer. How am I going to stop that thing from leaking? Probably not. This is the part where we flash back to me saying these are not complicated and it's probably going to be a simple fix. I'm pretty sure the whole problem is that this 20-cent diaphragm has a tear in it. I'm sure the solenoid was fine. The pump appears to be mechanically just fine. Yeah, I mean, this is what happens when you're working on something you're not familiar with. You know, if you work on these every day, I'm sure this would be the first thing you would check. But for me, it was an unknown unknown. Anyway, we're this far into it. Might as well try and figure out how this thing works. So it's a gear rotor pump, which is pretty common for like automotive engine oil pumps. Kind of works like half of a gear pump. The small gear is connected to the input shaft, and then it turns this larger internal gear, the rotor, and whatever we want to pump comes in over here, and it gets trapped between the gear teeth and this crescent moon shape on both sides. And then as it turns, it carries whatever we're pumping along the outside here, following that crescent moon. Then when it gets to the opposite side, it can't go any further because the teeth are in mesh, so that creates a positive displacement. And if we have a restriction, that would create pressure. So we just have an inlet here and an outlet here. Fluid goes around this side, can't come back around that side. Pretty simple. The purpose of the diaphragm is a little more confusing. You have to imagine that this thing is connected to an electric motor, and it may not have that solenoid at the bottom. That's kind of an optional accessory. So if we don't have the solenoid and we start this thing up, the motor takes a certain amount of time to get up to speed. And the pump's pumping all the time. So while it's coming up to speed, it's just kind of dribbling out fuel or kind of sputtering out, and that would not make for very good combustion. So they put this diaphragm in here with a spring, and the pump has to make a certain amount of pressure in order to push on this spring, which pushes this piston here against this little port and closes that off. And then the flow is diverted basically over to this pressure regulator and out through towards the nozzle. And the whole purpose of the diaphragm basically is to make sure that the pump doesn't spit anything out until it's very close to its maximum RPM. That way it just comes all on, all at once, and you ignite it and you get a nice clean burn. At least that's how I see it. Maybe I'm way off. Anyway, I think you can buy this diaphragm. You can actually buy a whole kit to rebuild this, which has a seal for the shaft and a new strainer and stuff, but I couldn't find anybody that would actually sell it to me other than some dodgy sellers on eBay. So I don't know how I feel about that. Instead, I chose to just buy a whole new pump. It costs about 125 bucks. If I had unlimited time, this pump could definitely be rebuilt, but the thing's torn apart, it's in the way. I want to get it put back together. I wish I knew where you could buy this material that this diaphragm is made from. It's only like 0.15 millimeters thick, 6/1000ths thick, and it's almost like plastic that's been laminated over top of some kind of fabric. It's very similar to diaphragms you find in carburetors. If I had some of that material, I could just make my own diaphragm, and we could have fixed this thing for basically for free, but I have not been able to find it. Anyway, let's put this thing back together. So this adapter goes onto the shaft like so, and that's nice and loose. Yeah, I'm sure it'll be fine. Okay, and then this is the drive shaft that hooks it up to the actual drive motor. So like that. Ooh, you know what? Bypass plug. Okay, this is a 2-pipe system, so it has a supply and a return, which means we need to install this little bypass plug. So in a single line system, it bypasses internally. Functionally, there shouldn't be any difference between the single line and the 2-line system, but having this return line should make it bleed out a little easier, which is probably good for this machine because I'm not very good about checking the fuel level. Okay, I think that's it. Let's try it. That's all it's got to do. Cool. Let's maybe service the pump. It's been a while since I've done that. there isn't a drain plug on this pump. So the best way I've found to get the oil out is with a fluid extractor. Just got a new fluid extractor. This is a Mighty Vac, I believe. My old Astro one won't pump anymore. I can still use it, but I have to use the air Venturi because the hand pump doesn't work. I think that's it. So this is an Italian Novi Riverberry pump, and it says to use SAE 20U40 oil, whatever that is. So what I do is I just use non-detergent air compressor oil, which is probably wrong, but it's been working fine for the last decade or so, so I'm going to stick with it. Doesn't hold very much. No dipstick on this one, but there is a sight glass. Kind of hard to see in this configuration. Probably can't see that, but it is full. So this pump can put out, I can't remember how much pressure, 140 bar, which is really not a whole lot, which is why it's kind of important to have the hot water system working, especially if you're dealing with a lot of oil and grease. You know, I've done some sandblasting. You can't even sandblast through caked on grease, but with heat, it'll cut right through it. Okay, let's give her a little shakedown. Scoop out some of this good stuff. Gonna need that one and that one. There you go. I picked up this Onefinity CNC router earlier this year. It was in a basement, and it turned out to be quite a bit heavier than expected. So in the process of moving it, we kind of mangled the bench. I finally had time to build a new one. The top is what's called a torsion box. So it's a lattice of powdered tree carcass sandwiched between two pieces of plywood. Despite my poor woodworking skills, it actually came out pretty straight and pretty stiff. I'm just squaring up the rails. This is probably overkill for a hobby class CNC wood router, but old habits die hard. Prepare for Chinese carbide shrapnel in your eye. First cut on the Onefinity CNC. Well, that appears to be worthless anyway, so. It's not too bad for our first go around. Spoil board is reasonably flat. It's got a little bit of a cusp, so I think we need to trim the router, but I can take care of that. It does work, but I absolutely hate this controller. This thing is just a joke. It runs in a web app, which is, I mean, I guess because they want to be able to do it from your phone or whatever, but this thing is abysmal. So you have your start and your stop controls down here, but then you can't see the position. There's no graphics. There's no distance to go readout. There's no overrides. There's no single block mode. Like once you push the go button, it's going. And you can pause it, but you can't slow it down. There is really not much going on inside this controller. That's a Raspberry Pi 3 single board computer. It handles the graphical user interface through the HDMI and the user inputs through USB for loading programs and dive into the Titanic. Then it's connected through a ribbon cable to this board, and this microcontroller here does all the real-time stuff, you know, controlling the motors, and then behind it is a DC power supply. And that's really it. All the stepper drivers and stuff are on this single board. Yeah, I mean, it works, but like I said, there's not much to it. I don't know. Then I got to see what's going on with my cam system because it's spitting out little short line segments instead of circles. So this program should have only been about maybe 100 lines of code, and it's 3,600. So I got to figure that out. Now we have a CNC router. I also got the laser set up. I built a little gizmo to fit into the window and then ran some flexible duct so we can vent that thing. It works. And I also moved the 3D printers again, I think for the third time. Hopefully that's going to be their forever home, as we're going to need all of these machines in the next couple of weeks to finish up these, which are going to finish up these. We'll talk more about that one later. Thanks for watching. I don't think that's how it works there, kiddo.
It pretty much is. Got us. Yeah.
Tell Dad what you said about how to change the oil.
Is Mom trying to pawn her chores off onto you?
Yeah, I don't like it. Because I'm going to get $1. The better.
World's cheapest oil change. Dust collection saw.